Today, I did touch on briefly on Thursday on undamped force vibration. Okay, so I'm going to do a bit of recap. So the system we have is undamped. Okay, it means there's no damper. So our system will generally look like this. So we have a spring, and then we have a mass, and then we have stiffness spring, and this is our Y displacement. So from here, as I mentioned before, this is a undamped force vibration. So when the term force has been made used, we have a force function over here. And the force function that we have is F is equal to F naught sine omega naught T. Okay. So basically, this is the amplitude of the force. And this is our frequency of the force. So we wrote this out, right? So the characteristic equation is in the form of md squared y over dt squared plus by ky. We drop the damping term, okay, because there's no damper. And this will be equal to F naught sine omega naught T. So we know for the general solution, for undamped system, we know that it takes the form as in y as a function of time is equal to C1 sine omega nt plus by C2 cos omega nt. And omega n is equal to square root k over m. And this looks familiar, right? This is our natural frequency. Okay, this is known as our natural frequency. Okay, so I'm going to call this our equation number 1. Okay, so if I were to rearrange, okay, if we were to rearrange equation number 1, right, we bring down the m term. So we have d squared y over dt squared plus by k over m y, and this is equal to f naught over m sine omega naught t. So we're going to let the particular solution be y as a function of time is equal to x sine omega naught t. Okay. And we last week, and we choose this particular solution because we have what? We have complex conjugate roots. Okay. And when you take your math course, you'll go deeper into it. I just introduce you the formula or the form. From here, when we differentiate once, okay, and I'll tell you why I'm differentiating later, you will see why. This will become x omega naught cos omega naught t. This is our equation 3. And then we differentiate again. this will become minus x omega naught square sine omega naught t. And this is our equation number 4. Okay. So from here, we're going to substitute equations 2 and 4 into equation number 1. Okay, so we're going to put 2 and 4, right? Equation 2 and equation 4 into equation number 1, or yep, into equation number 1. So when we do this, we will have this form, okay? So we have x minus naught square sine omega naught t. Okay, then we have plus k over m. Y is x sine omega naught t. And then the whole thing will be equal to f naught over m sine omega naught t. Okay, so don't get confused. Omega n is not equal to omega naught. Okay, some students tend to this is the natural frequency. Omega n is a natural frequency. Omega naught is a forced frequency or forced input frequency. So some of you might wonder, what is omega naught? Okay. Or if you drive, or if you can drive, driving is important. It's as important as swimming and biking. Okay. When you press the accelerator, what changes? What changes? The revolution of your what? Engine, yes or no? The more you step onto the right pedal, the higher the what? Revolution of the engine that's rotating. That is your omega naught. Okay, as mentioned earlier, I drive a car that's more than 10 years old. When I hit 2,500 RPM, what happened? It vibrates a lot. Okay, so that is a frequency that I have to what? Avoid. Are we clear? Okay, so the omega naught is what you desire. Okay, omega n is the what? Is the system, how the system will react. So we are fortunate enough that this expression, we have what? The common term is what? Right? So the beauty about math, you have the same term on the left-hand side, you have the same term on the right-hand side, you can drop it. Okay, so we have minus x omega naught square plus by k over m, and this will be equal to f naught over m. Okay. So I have an x missing. Okay. Going to factor out the x, or take out the x. So this thing will be k over m minus by omega naught square. So one thing we realize is note that we have a term that omega n squared, okay, omega naught squared is equal to what? K over m, right? Or omega n is equal to square root k over m. So when we substitute that term in, x will be equal to omega n squared minus by omega naught squared, and this is equal to f naught over m. Okay. Then this will be x will become f naught over m. This will be equal to omega n squared minus by omega naught squared. Okay. Rearranging the term a bit, f naught over m. We have omega n squared on the outside. Okay. And then what we do is 1 minus omega naught squared over omega n squared. We are going to rearrange the term slightly. Okay. So we know that, note that we have omega n or omega n squared is equal to what? K over m. And we know that m is also k over omega n squared, right? Or if you look at the term or, you can also have omega n squared multiplied by m is equal to k, right? So if we were to gather this term together, right, our final expression will be equal to, I'll let you guys finish copying first. Okay. So if I were to write one more steps over here so as not to confuse any of you, right? We know that this will be equal to f naught over omega n squared multiplied by m, 1 minus omega naught squared over omega n squared. And we know that omega n squared multiplied by m is equal to k. Okay. So from here, we can write out x, right? We replace x will be equal to f naught over k, 1 minus omega naught squared over omega n squared. And we can, generally, you will see this in this form. Okay, so that is our x. Okay. So note, if you were to look at the units, can someone tell me what's the unit of x, please? Right? Omega naught squared over omega n squared is unitless, right? It cancels out. The top, you have what? You have f naught over k. So this is Newton over what? Meter. So cancel, you have what? You have meter. So meter is a displacement from here on, okay? So from equation number 2, right? So remember equation number 2, we have, now I cannot remember, pardon me, okay? So if we were to go back to equation number 2, we have y as a function of time. This will be equal to x sine omega naught t. And when you substitute the function, or you substitute x into equation number 2, what you tend to have now is y over t this is equal to F naught over K over 1 minus omega naught squared over omega n squared, okay, sine omega naught t. And I don't usually use the term it makes sense, but it's valid, right? Why is valid? Because the units here is in what? In meter. Okay. So therefore, the general solution for undamped force vibration will be equal to y as a function of time equal to C1 cos omega nt plus by C2 sine omega nt, then plus F naught